Hi, everyone. Thank you for joining this session. This is the introductory session for the Timechain Summer of Code Fundamentals of Blockchain program. We'll be having 4 sessions. This is the part 1 of that session. If you're all excited, say yes in the comments section here, and if you can hear me also. So we'll begin once we have at least a few yeses in the chat box. Who all are there with us. So let's see. Nikhil, Manasvi, Mahesh, Dimple, Aditya, Pushkar, Sakib. I hope I'm pronouncing your name right. Aditya, Sanskar, Parthiv, Sanyog, Abhinav. There is someone named Void, Anurag, Shubham, Vibhav, Nalam, Aryan, Rohit. Yes, so nice to meet you all. And let's begin the session then. So today we'll be going through the fundamentals of blockchain. Even if you know nothing, absolutely nothing about the entire story of Bitcoin, blockchain, or anything else regarding that, you will be a pro at the end of the session, at least to the level that you will know a lot with respect to the fundamentals, how they function. You'll have enough material to even research on your own and figure out things by yourself. Tomorrow, we'll be having the hands on session where there will be a workshop, there will be a script, the code. We will use the gist, the SDK, to develop and deploy a transaction on the blockchain. But today, it's going to be the fundamentals and it's going to give a background of why blockchain in the first place, what you can do with it, the history of it, and many more interesting things that will come along. So let's begin then. Let me just share my screen. These sessions will be available on YouTube. The last session, the introductory session of the program itself, is also available right now on the Timechain Labs channel. So you'll be able to find all the sessions live streamed on YouTube available. Think there is a little bit of a difficulty here. I'll have to share my entire screen. Please let me know if you're able to see the screen, and I'll continue the session then. All right, let's begin then. So, introducing myself, if you guys missed me and are not aware of who I am, I'm the founder and CEO of Timechain Labs, one of the companies building blockchain solutions in India on the original vision of the Bitcoin protocol. We build different solutions. We have a wallet infrastructure as well, with which you can develop different solutions on the blockchain. We've been in this space since the past 8 years, and there's a lot that we can do together. So, Bitcoin is how it all started. The entire term blockchain comes from the innovation that was done by Bitcoin. The white paper and the protocol of Bitcoin functions as a peer-to-peer digital cash system. Who is aware of Bitcoin? Or more likely, I should ask, who here holds Bitcoins, any amount of Bitcoins, or any cryptocurrency for that matter? Please say yes in the chat box. Let me just see. Yes, okay. And there's one discrepancy I would need to sort. I think there's some questions I need to address. How to give attendance? It will be shared in the middle of the program. Lot of currencies. Okay. Okay. You will also get to know there's also multiple versions of Bitcoins. We'll be talking about all of that as well. Multiple cryptocurrencies. Let me go back and continue. So there's quite a few of the people who already know and hold Bitcoin. Only in the development account, of course. Well, one Bitcoin's price is quite a lot. So that is expected. Just a second, guys. There is a glitch while we're trying to get back on. Crypto banned in Nepal. Well, that is true. There's a lot of problems also that come with not having a regulated currency. We'll be talking of all about all that. There's a lot of controversies around the system as well. A lot of support, a lot of adoption, a lot of problems. Okay, I think we're good. We're sorted. Okay, continuing where we were at. So there are different layers of the internet right now. Have you heard of the HTTP protocol? If any one of you has been a developer before, there is layers of stack on the internet that makes up the internet entirely. Ethernet is the fundamental layer which connects different computers. Then comes the TCP, the transport layer, the IP layer, the internet protocol itself to transfer packets on the transport layer. And then comes the HTTP, which is what powers all the websites. If you see when you type, let's say even in Google, HTTPS, it's following the HTTP protocol, the hypertext transfer protocol to transfer. That's the layers of the internet that makes up the internet, right? Now, since the beginning of the internet, while we had all these layers and we tried to do commerce on the internet, the first attempts were done to sell a pizza, let's say. And the pizza was sold, the guys met, but they finally exchanged money physically. They exchanged money in hand by cash. So we didn't have digital systems in 1994 when this first transactions happened. Starting the sale online, but then exchanging the money offline. This was a problem until the internet boomed. And that really happened in 2006, then when it really began. The commerce on the internet began with PayPal. Even Elon Musk, all of you are very well aware, is one of the people who got benefited and the companies that really transformed the internet by introducing digital payments on the internet. Before that, there wasn't ability to make payments on the internet. And that's a big leap. Now, this is the problem that has been getting solved from way back. Even before PayPal came, and even after PayPal came, there are still problems with how the system works with cards. So let's go back through the history of money entirely and look at the history and where we are at, because the innovation that we are talking about is happening on the layer of money on the internet. And that's what is the story and the origin of that. For those who are not new to this, we'll be quickly going through the glimpse of the main points. And for those who are totally new to this, it will be a very interesting story of how money has really evolved and where we are currently at. So we started from the ages when we used stone as currency. Different types of stones which had to be scarce because you can't really have a money system in society where it's easy to manufacture the money that anybody can manufacture, because then you can't hold value. money can't hold value if anybody can manufacture anytime any amount of money. So it should be able to be counted. It should be not easy to manufacture. It should be easy to transfer. It should be durable. It should last. You can't use just a corn or something that gets wasted in a few months, so that you can't hold value in it. That's why you need to hold value in it as well. So those are the properties that are the natural properties of something to be money. Now, what is money in the first place? Money, by many definitions of it, there is multiple competing definitions of what money is. But fundamentally, when we use money in a day-to-day life, it is used as a means of payment, which is a means of exchange, to make a transaction, an exchange between two goods. There is a fundamental need of money will come down later on in the society that originates just because of the nature of commerce, which is called double coincidence of wants. That is a concept in economics. I would like you to do a homework also of studying what that really means. But we'll be going forward right now. So from that, the stones, we started with more metal coins, which were etched and more difficult to create. Only the emperors or the kings were creating those coins with metal coins. Metals is more rare than just stones, right? Particularly metals that are even more scarce become more prominent because they are even harder to manufacture and duplicate. And particular emblems were given by the coinage, was given by the kings and queens for their jurisdiction, so that the money supply in their kingdom remains very progressive. Then comes the age of paper money, which started just about in 1900s, when the pound note and the dollar notes, and starting with dollar at first, came across in the picture. Even before that, the first promissory note was issued in China, the Jiaozi promissory note. Like that, there has been an evolutionary of promissory note systems as well. With that, we have come down today to having notes and coins in our paper currencies issued by the central bank. Now, the first concept of the central bank started in 1913, the Federal Reserve of USA. And then multiple countries adopted this system and have now central banks in every country. Now, central banks are the central bank that issues the nation's currency, which is the RBI, the Reserve Bank of India for India. And like that, there are central banks across the world who issue their currency. Now, there are different economies that these currencies cater to. Like in India, we use rupees as our currency. And in other jurisdiction, we use other currencies. You can't use rupees to do a payment in other jurisdictions. So that's how there is the economy that get zoned out and managed and regulated through a currency. So that's how the national economies work today. The issuance of the currency is done by the central bank, and there's no specific hardness that is associated like it is with metal coins. So there is 10 rupee value of money. It's not actually backed by 10 rupee worth of metal. That's the coinage that the central bank or the reserve bank gains or has as a cost to manufacture the currency. Now, going forward from all of that, we are today in an age of fiat currencies. The currencies issued by the national central banks are actually called fiat because they're issued by fiat, by somebody. It's not natural commodity on its own, like metal or a coin, um, which has its own intrinsic value and with not having a face value on top of it, which has been given to it or given to it by fiat or by diktat or by some rule. So that's what is the current economy powered by. Now, that is accepted for taxes as well. That is accepted as legal tender for paying off the obligations by the legal system. They recognize that you can pay by this currency and that will be accepted. So that's how the entire system works. Now, it relies on a system of ledgers maintained by the central bank and also maintained by the banks. Each bank we currently have an account in is also maintaining a ledger of their own and of ours as well, individual ledgers. So that's what is creating and powering the fiat currency today, which is background of our economy. These financial ledgers have their own story. Going away from the coinage and the coins, there is another history to financial ledgers as well. They have started since 3000 BC, where the first ledgers are recorded to be maintained. And you can have the modern systems in which the computerized versions of the ledgers have been started to be made. And that's what we have the digital ledgers right now in computers across the world, in different banks, in the central bank, right? And that is what is getting used to track who owns how much. Now, if you think about it, that is becoming a little more insecure than a very secure system, which is physical metal coin with you. And it's held by ledgers, and the ledgers are maintained by entities other than you. When you own a coin or you have a note, you have the note. And it's not at the discrepancy of some error in the ledger system maintained by somebody else that you might not suddenly have a coin or the note or the money. So there is a difference you can already see that happens when you become or use a ledger, particularly a digital ledger, which is not a physical commodity. But still being able to do payment and settlements with that requires us to send notes and signatures with that, which are also known as checks or demand drafts. There are many ways, message names that are given to it. It's the same thing. There is a note with a message and a signature, particularly signing off the message that, okay, this is an authorized transaction, and that's entered into the ledger, and the ledgers get updated. Now, this is what is becoming digital as we go forward. Now, credit cards are now the prominent way of paying. Even PayPal, when PayPal introduced the system to do payments and commerce on the internet by businesses, it introduced it with credit cards. Now, credit cards have backing of a bank that issues the card and settles the payment. But the payment actually happens on credit, and there are different fees involved to make the transactions. And credit payments are also reversible. Reversible payments have their own benefits and problems, which help as well as detract usage on the internet. What Satoshi Nakamoto set out to do was to set out an irreversible payment system which cannot be reversed. We'll come to why that was the case. But coming to how the processing happens, right now you can process cards physically with these machines, in which essentially it's acting like your authorization. Only you have the PIN, so you authorize or you sign, somehow authorize the transaction to happen from your account, somebody else's account. And then there are different variety of intermediaries who then make sure the payment happens, and the ledgers on both the banks, on both the sides, are updated. And that's what essentially makes the transaction. This was happening as a evolution of technology. Meanwhile, there is a parallel track which was happening of cryptographic evolution. You can even do the authorization of the PIN codes even digitally with just cryptographic signatures. That was what happened as the innovation in cryptography, which got adopted into payments. And that's what is now going to create the payment system that we're going to see, which formed Bitcoin. So there is a knowledge of cryptography required to understand Bitcoin, and that the most important thing, well, two things are the most important: hashes and signatures. Hash we'll understand later, but a signature is done by a cryptographic key pair, which was innovated as asymmetric cryptography in 1976, which can be used to either encrypt or sign different messages. When you can sign a message, you can even sign a memo or a check digitally saying that you're transferring this amount. And you can have digital ledgers maintaining, and then you have the security of you owning your coins and then being able to transfer it to somebody else with a signature. And that would function very much close to a cash system. That is the vision of trying to achieve a digital cash system, not an account based system, which is done by banks. There is a difference there. We'll come to that also. A digital cash system on the internet, which is peer to peer, just replicating the same physical nature of cash. Like you have a note of cash in your wallet, you give it to somebody, hand to hand, peer to peer, physically. And you have the trust, and you're able to get the other object in exchange for it physically right there, right then. And if there is any discrepancy, you don't give the cash. So that's where the trust issue also comes in. That is solved when it is physical, but when it is digital, it becomes a problem because you are getting objects not immediately. You are way far from the other person who is on the other side of the globe with another currency entirely. So we'll go through all of that of why there is a requirement of having a new digital money. So this was attempted. Trying to have a digital cash system, which is truly peer to peer, was attempted by many different researchers trying to solve this problem. This is the history on your slide given for the different types of attempts done by different people to start to establish a digital cash system on the internet, which wasn't really successful. BitGold, Hashcash by Adam Back, David Shom started with DigiCash, eGold started, which was really popular and was used for quite some time, but then it was shut down because of lack of regulatory ability to regulate it very well. That's why there's many properties that is required for a digital cash system to be successful. Now, Bitcoin is what made the dent really well in 2008. But before that, there are different reasons for not catching steam. DigiCash by David Shom had an absence of internet. It was 1999. It was not that spread, and not that much of an infrastructure was developed of the internet. There weren't that many ISPs, so it couldn't be done. And there are different reasons why it couldn't be done. eGold, as I was telling you about, had legal issues so that it can't be accepted by different governments. They didn't want it, so it was shut down. Many people in Bitcoin and the cryptocurrency space think that their currency, the cryptocurrency currency, can survive without having to follow law and regulations. But eGold and examples like that tell us how a very well spread currency also can be taken down. And it was taken down within a few months by the regulators. That is something to be taken care of as well. Hashcash was launched. There was a niche use case that was there for Hashcash, which was not there for money. It wasn't used exactly for money, but it was an interesting solution that got adopted and referenced in the Bitcoin white paper also, which is to use the hashing algorithm that computers do to prove that they have hardness or computation, or they have solved a computation puzzle in order to prevent spam. This is how it started, to prevent spam in emails. The Hashcash solution essentially made that if you're sending an email, you can even be spending a spam. We'll put a cost to make that email sent, and that cost will be checked by the computer. Because the difference between an attacker who is doing spams at a large scale and one who is genuine is one important thing, is that they are able to replicate and they have to do things at scale. A spammer has to send spam. The definition of spam is to send it at scale without relevance, is to send it at 10K, 20K emails. If you're trying to do that and there is a slight cost introduced, it multiplies by 20K and it becomes a huge cost for the spammer. But that stops the spam because the person who is genuine only needs to send one email. So they're able to easily send that one email, and that's not a problem at all. That is what reduces the amount of spams. That's the Hashcash solution in email that was introduced. Now, this was an idea that Satoshi Nakamoto, well, a person who we don't know who is behind that identity, launched Bitcoin as the cryptocurrency, the digital cash system, which uses some of the concept of hashing used in Hashcash. There were B Money and other technologies also who tried to achieve it, but it wasn't really done successfully for a variety of reasons. So we can summarize why all of these really failed. Lack of technology, lack of merchant adoption, of people accepting it, lack of different regulations that could support it. Those are the different things that really stopped it. PayPal really did come and solve it, but there is the cryptographic protocols which can be used to do it in a way that is truly peer-to-peer. Because PayPal, the way it did it was with a banking system and account-based system, and with central intermediary, while using cards, not just one intermediary, multiple intermediaries who all took a lot of fees and have 3% or more transaction fees to be able to do commerce on the internet. Plus it's reversible transactions. So if you don't like the product, you can be reversing your transaction, and it becomes a cost to the seller. Particularly on the internet, we'll come to why it becomes a problem. Reversible transactions on the internet are good for real world goods, but it becomes a problem for data economy in particular, because the data, you have already loaded the website, you've already consumed the content, and you can't reverse the payment right now because you've already consumed or got access to the content. Now reversing the payment is something which is for an irreversible service. You're trying to do a reversible payment. That's why it was very becoming very critical to have a natural data economy. You need to have a reversible irreversible payment system, and that's what the creator of Bitcoin set out to do. Now there are multiple different other things that it needs to do to be able to achieve what it wants to as a digital cash system for the internet. We'll come to that also. But yeah, let's go into why the PayPal based system or the banking system has the problems. First, it is not really peer to peer. There's multiple intermediaries, as I pointed out. There can be a failure of the bank, and then there is also failure of being able to have a neutral currency. That's a very important point as well, because the person who's accepting the transaction is in USA. He's a server in USA, and the other person is in India, let's say. You are browsing a website hosted in USA, and the payment that is going to be needed there is in dollars. The payment that you are trying to do is in rupees. There is no intermediate currency that is neutral, which can be used between both of you. So then there are exchange fees that also come into the picture, and that's why international payments is such a huge cost and also very slow, because it goes through multiple ledgers, multiple authorizations with all disconnected ledgers, and then it finally gets sent with a lot of payment cuts. And that's why the settlement is way delayed than the payment. When your credit card authorizes a payment, you get the authorization immediately, but the payment actually doesn't happen until a few days or even weeks in many cases. When the actual payment, the ledgers get updated and there is an actual record of payment, the settlement, which we call it, happening. That's the difference there. So the global internet needs a neutral currency, and that's where the need of Bitcoin really comes in, of needing a neutral currency which is not having bias towards India or Japan or US. It's behaving as a neutral currency that can price data and functions for the data economy, for irreversible payments, for irreversible services on the internet, which can be used to make up the data economy. So that's what really sprouted the need for Bitcoin to come about. Now, the innovation of Bitcoin was coming after the innovation of the different payment solutions like PayPal and different wallet solutions, even UPI that has come in right now. These all fall under the category of national payment systems or card payment systems, which use non-blockchain based payments, and they have the same problems of having high cost, slow speed internationally of doing payments. The cost is not felt by you, the payer, but it is by the seller, the receiver, who's having a high cost because there are so many intermediaries involved to do the payment, as well as there are a lot of restrictions that come in for a payment to be successful, which is not related to the proper functioning of the business or the customer and their needs, as well as the regulations of how they are met. That's where the real innovation came in of the blockchain technology, which is the ledger powering Bitcoin, as we'll look forward in the following slides. In this slide, we have mentioned how neutrality, scalability, risk of bank failure, and being online to verify. A bank would always need to be online. If the bank server goes down, the payment wasn't going through. So that's a problem. And that's why it couldn't scale as well. Imagine if you had an email server, and globally that email server is getting used by everybody, and it has every transaction or every email has to go through that server in order to reach you. So that becomes a bottleneck. That becomes a big bottleneck for it to be able to process transactions. That one single server has to process everybody's email, and everybody has to contact it and be able to get whether the transaction is valid or not. And that is not possible because there are multiple different scalability requirements that not just one server can satisfy. It's not robust enough, and it can't satisfy the demand with the requirements of the internet. So right now the internet is also formed with a peer-to-peer email system, which is very much formed by everybody having their own email servers that they're running, or having a service provider running it for them in most of the cases, but still enough decentralization for them to be running email service and receiving emails peer-to-peer directly from one server to another server, and there's no middle server that every email has to go through. So that's what creates the scalability and robustness of the email system today on the internet. And a very similar system is happening if you're trying to establish a digital cash system, which is peer-to-peer, where ledgers are, let's say, maintained by different entities. And there's not just one ledger that's updated with a single bank that needs to be online always, and it has to process the whole world's transaction. So that's what is going to achieve a distributed ledger system which can process transactions globally for the internet. So the riddle remained of how can you have a peer-to-peer system of ledgers without a central intermediary. Why? Because it's not just an email system. So with email, there's no problem with you sending an email and then sending a copy to somebody else and then sending multiple copies to multiple people, and that's not a problem at all. But with currency or with anything of value, because it is of value, you can't really replicate it without a cost. So you can't send a coin to somebody and try to send the same coin to somebody else as well. If you have a note, you're signing the message that you're sending this coin to somebody, and then you're sending another message to somebody else that you're signing this message, sending this coin to somebody else, then the history or what transaction comes first becomes important, because the next transaction is going to be invalid. So it can't be easily processed in the same fashion of how email was processed, because emails didn't care about the sequence of transactions. But the sequence of transactions matter when it comes to anything of value getting signed in a message and the message getting sent peer to peer. So the message sequence matters of the ledger maintaining it. Now, if there is a ledger sequence mattering, the most simple way to do it is by having a central intermediary, one central server. It will have to record every single transaction that happens, because it needs to be aware of what transaction came first and what comes next. So the most easiest way to solve it is actually to have a central intermediary. But then we saw the problems that come with a central intermediary. It can't be scalable, and it's not robust to solve the problems we're dealing with. So how do you achieve something like the email server system we have today without the problem of a central ledger to be processing everything, while it's still being a central ledger without it being a central bottleneck, essentially? So that's what Satoshi Nakamoto set out to do. And that's what he successfully created and launched as a fully peer to peer electronic cash system with no trusted third party. He titled the white paper as a peer to peer digital cash system, and he launched it on a forum on the internet in 2008 in October. And just next year, in 2009, the blockchain started, or the blockchain is the name for the ledger that's powering Bitcoin. And that started after launching the white paper, the computer system started, not just at one place by Satoshi Nakamoto, but as a public competition between multiple different servers. Anybody can start up a server and anybody can run a ledger, just like anybody can run an email system today. This Bitcoin system started in 2009, has grown to prominence and known across the world as the most popular and sought after currency, but with a lot of controversies as well that come with it. We'll come down to why it succeeded technologically, but why it failed also. Again, in many respects, technologically. That blockchain is the ledger that's powering Bitcoin. Now, as we noticed, the importance of transactions to be appended or added in a sequence is what created the append only ledger. That is the blockchain. Now, that is an auditable ledger that is having consensus between different parties because the ledger is getting maintained by different computers across the world. But they still need to have a single source of truth. They should have consensus among what is the first transaction, what is the next transaction. That is what created the demand for the blockchain solution, which created a distributed timestamp server, essentially that timestamps messages that is coming in a distributed network and have consensus achieved in that distributed network, just like email has a consensus, but it doesn't have a consensus among different parties because you are all peer to peer and there's no central ledger coming into the picture. But here in this case, we are having a central ledger that needs to have a common consensus. The property of email solution of Hashcash, which was launched by Adam Back, of having a cost to make a transaction or send an email, essentially in that case, was adopted to solve the blockchain puzzle as well by Satoshi very easily, because he wanted to essentially achieve a email type system that has a central ledger. What if you introduce a cost to add to the ledger? What if you do the same thing that created the problem and solved the problem of spams in email solved previously by Adam Back? So, what if you adopt the same solution and it is messages that you're signing anyway, as even an email, you send an email, but what if the transaction is what you were signing as a message, and in order to add that transaction, you would have to solve a difficulty of a hash puzzle to be solved in order for the central ledger by everybody to be updated. Now that difficulty can be a cost. So why that cost is needed is because the spam of different proposals of ledgers could distribute the ledger into multiple different directions. It could totally distribute the ledgers in having no consensus. So you should be able to have consensus and come down to a single shared global ledger state as a central ledger. So there is a yin and yang happening here, that is between decentralization of ledgers, of having multiple copies of the same ledger. Though there is centralization of the ledger, it's a central ledger but maintained by multiple different entities that need to get consensus. So that is the problem that he solved with the innovative technique of proof of work, which got adopted from Adam Back's Hashcash, of solving a hash puzzle of computational work to be done in order for the appended block to be accepted. What is the blockchain is very simple. It's simply a chain of blocks that append the ledger, with one by one block having a list of transactions that accumulate over a 10-minute period, approximately over a 10-minute period. And that's what creates the entire ledger history starting from 2009 of Bitcoin. There is a single ledger maintained since 2009 till right now and running, with every 10 minutes a new block added to the ledger, adding a list of transactions that happened in those 10 minutes across the whole world. Now, the people who are maintaining this ledger, this append only immutable, also known as immutable ledger, are called miners and also called nodes in the Bitcoin system. Nodes or miners. Now, why they are called miners will come down to it, because they're solving just like gold miners mine for gold and dig out gold from the bottom of the earth. Like that, the miners are maintaining the Bitcoin protocol by maintaining the ledger, and they are adding to the ledger or proposing new blocks to the ledger. So the actions of a miner are very simple. They have to maintain the list of all blocks or the entire history of the ledger. They have to listen to the transactions that are happening currently, which are not added to the block already. They have to group it all up. They have to propose a block and broadcast that block to be appended by every other miner who is also maintaining the ledger. So they have to broadcast that. Now, if everybody can broadcast that very easily without any cost associated with it, you won't get to know the authenticity or the cost that gets associated with it. So you would get spammed with a lot of different proposals of different attacks happening. So that is what is called a double spend attack, where one person, let's say me, I'm trying to send the currency to you, the coin to you, but at the same time I'm making another transaction, spending the coin to somebody else. Now that is a double spending attack. Now that attack, only to solve that, we needed a centralized server, and only to solve that, we are also having the entire decentralized ledger system created without a central intermediary or central ledger needed to solve the double spending problem. Now the double spending problem gets solved when we have a proof of work attached, which is making a consensus dissolve to a single state of the ledger that multiple different parties are maintaining. Now, that cost has to be enough that it's centralizing the ledger every 10 minutes or so. That's an approximate number. But if the people are able to solve for that cost and make it more easily solved, if the computational power of people increases, if the computers become more powerful, the puzzle should also be having a adjustable difficulty, that it should adjust in such a way that the ledger is still able to converge in 10 minutes or so. That is what creates the solution of the blockchain. Now, we look at the layers of the internet and where blockchain or Bitcoin fits in. So, Bitcoin essentially introduced transactions as the layer of money on the internet, in the layer of the protocols of the internet. Programmable transactions is something else that Bitcoin also introduced, because it can do payments which can be programmed with code, and now you have control over your transactions and you can code for when the transaction should happen, let's say when you do a click and when you do not. So that is what the innovation that happened, of a programmable layer of money. But not just of money, it can also tokenize and represent other assets on the blockchain, and you can track on the ledger other assets. And that's what creates the ledger system that powers the internet economy of not just money, but of different commodities, different objects, different people are selling different things. All of those can be represented on a single globally shared ledger of the blockchain, and they can be exchanged with money. Now, the natural native currency of the ledger is Bitcoin, which is the incentive which miners are getting to host the software, host the ledger, and support the network of Bitcoin network to power the system. Now they need a system, they need an incentive. Why should they be running the entire cost? They should do the mining operation and be supporting the network. They need an incentive system to be powering them. So while Bitcoin was getting launched, the Bitcoin network by itself, the Bitcoins, were issued to the miners who first create the blocks. So every block producer who proposes a block is able to get coins or Bitcoins for creating the block. And that's how Bitcoin, it does two things. Bitcoin comes into circulation and also incentivizes miners to serve the network by creating blocks and solve the computational puzzle. So that's what bootstrapped the network and brought the coins into circulation. If you look at the layers of the internet, you have TCP/IP, the transport layer, the application layer, the physical layer, and like that itself, we're transporting information on the internet. But you can also transport money or different tokens on the internet. The transport layer of the internet that transports not just information, but also money or anything of value is what becomes the blockchain layer. So that's where the future is. But in order for the currency of Bitcoin, when it came into the picture, to get a value, it doesn't have any value initially. Miners are mining it, they are getting coins for solving the computational puzzle. But for it to get a price, there needs to be having a real world transaction happening with in exchange for Bitcoins. So the first transaction happened for pizza, again repeating the same history of the internet. The previous transactions were all happening physically, but if you can do a digital transaction with Bitcoin on the ledger in exchange accepted by somebody physically, then you have a price of Bitcoin because the pizza got exchanged for 10,000 Bitcoins. And that's what gave it a price. So the pizza was $41 or $20 per pizza because there were two pizzas. And that what gave it a price of 10,000 Bitcoins for two pizzas. And that's the first price of Bitcoin that got created in the market. And then you had different people creating different exchanges of value, and Bitcoin started to get used as a currency or a system of exchange, a medium of exchange, satisfying the properties of money. Well, that was till about 2014 when it was really in full use. And then the adoption, interestingly, did stop. It didn't expand that much. There were many companies that were accepting it, but then there were different problems that the Bitcoin network hit. We'll come down to it as well as we go through the journey of the blockchain, which is known as the Bitcoin ledger. The technology underlying Bitcoin is called blockchain, which is very fundamental for you to understand. Bitcoin is separate from blockchain because there were different blockchains that were launched after Bitcoin as well, which have their own currencies and their own network effects, and which have even different systems of consensus. Like proof of work was used in Bitcoin, there were different consensus used for different networks. The blockchain has a sequence of blocks, as you can see in the diagram, and it diverges at the tip. The tip has a divergence, which is the natural state, of multiple blocks competing to become the longest chain. But the longest chain is achieved by the maximum hash power that is able to create blocks the fastest. So it's able to achieve the longest chain the quickest. And the network naturally converges, the miners naturally converge, the different ledgers naturally converge to the longest chain because there is a cost associated by following the chain which is not going to be the longest, and that's going to be orphaned. That's what converges the blockchain, and that's what the elegant, robust system of blockchain creates a central ledger maintained in a distributed fashion without needing a central party. That is the core of blockchain. But why the hype? There was a huge hype associated with Bitcoin that came into the picture. Now, that's nothing to do with technical researchers thinking about wow, beautiful the blockchain system is, and it can solve this problem of a ledger, a central ledger, without needing an intermediary. The real problem of the hype, of the why the hype came, is because of the nature of what Bitcoin is. Bitcoin had also scarcity of the amount of Bitcoins that are available on the internet, available in circulation. And that's created also for a reason, because Bitcoin can't be issued by any central party because it has to be a neutral entity that issues it, and the algorithm for issuance has to be fixed. It can't be changing. So if the algorithm has to be fixed, the circulation of how it comes into circulation is pretty much fixed. Now, there are only so many ways you can create a fixed currency system, or a way in which the algorithm at least is fixed, even though the currency total amount might not be. But it does give a limit of consistency of how the currency comes into circulation. So Bitcoin, the way the algorithm was written, Comes into circulation 50 bitcoins per block in the first 4 years, then 25 bitcoins per block, each block being approximately targeted in difficulty to be 10 minutes in difficulty. So every 10 minutes, you're having 50 bitcoins. Then every 10 minutes after that, 25 bitcoins. It gets halved every 4 years. So every 4 years, you're having 25. Then the next 4 years, you're having only 12 bitcoins per block. Then you're having even lesser, 6.5. Right now, it's already 3.125 bitcoins per block coming into circulation. These are the new coins coming into the circulation. But then there is miners who can earn also from the transaction fees from different transactions getting paid by the people who want to have the transactions added to the ledger, to the shared global ledger. So there is essentially a demand and supply of ledger space that happens here. And that demand and supply is what gives the price, a strong price to Bitcoin, because Bitcoins are needed to pay the transaction fee to the miners to mine the transactions. And there is a supply limitation of how many coins can be used because the coins are limited in supply. But there is different philosophies that emerged from here, because when the hype was at its peak, it could not satisfy the properties of what it set out to be. So Bitcoin targeted to be ideal money, but it had some problems. Let's first discuss what an ideal money system is. Ideal money is the most sellable commodity on the market. How do you define that? If it is accepted by most exchanges in most transactions, then it is the most sellable commodity on the market. Then it naturally becomes a medium of exchange because it can solve the double coincidence of wants. It can essentially route demand. This is a problem in economics that you can research, and I encourage all of you to research what is double coincidence of wants and how that is solved by having a medium of exchange in between transactions. It's very simple concept in which you have me as having a want. I have, let's say, a requirement of shoes, but you have shoes, but you don't have what I want. I want actually a TV. I want shoes, but I'm giving you a TV, but you don't want a TV, you want something else. So we don't have a natural exchange happening with barter here. We have a problem here. We have a double coincidence of wants not happening. And if that is the case across different transactions, many transactions, the transaction cost is really high. So somebody needs to then figure out how to get what I want, get that, do a transaction, then give me the TV, or get my TV and give me the shoes, and essentially try to do two barters. And if that is also not possible to do, there's a routing problem here of double coincidence of wants. So you have to route not just by one person, probably by 3%. It can be a very difficult problem also to solve through barter. That's what gives money its property, that everybody wants it. So since everybody wants it and it can be priced, it can be exchanged. So you can just use a middle currency to exchange it. Even though finally I want a TV, I can still exchange it with a middle currency that everybody wants, which is money, which can be priced, and I get it and I pay it to somebody else, and it solves the double coincidence of wants. So that is the core of money. Now it has certain properties. Now when you have a money which is satisfying these properties, there are different properties that get associated with it. It should be at least divisible because we should be able to price different things. Now, interestingly, if you want to have a global economy running on a global currency, the best currency, it should be able to price the smallest item possible to be sold, which in this case is data. It should be able to price the smallest bit of data as well. It should be durable. It should be able to be lasting, because you can't be having a currency, or let's say used as corn or something like that, which is going to not be available in the best state in 3 months from now. It should be durable. It should be portable. You should be able to transfer it. It should be scarce, because you should be having value held by it. It should not be something that can be created by everybody. It should be neutral, since it has to be accepted by people maintaining different ledgers across the world. It should be global and accepted. It should be regulated also. That's where some I have marked the crosses where Bitcoin, as the popular version of Bitcoin currently, didn't hit the mark, because that is something that governments do. Governments, why gold cannot, if gold has all these properties, gold was divisible, it was durable, it was portable, it is scarce, though there is some debate that can be done there. It's not divisible to the level that it can price everything. So fiat currencies are able to price things better than gold. They can price things at a very small granular level, and that's something Bitcoin has to compete against. It should be able to price everything at the smallest level. It should be as durable as gold. Gold is not portable. It didn't solve the portability problem, and that's where fiat really beat it also, because it was more easily portable. You can easily transport paper much more easily and give it to somebody and pricing it for a smaller amount also, than having the risk of gold and so much cost involved with even pricing small things. So fiat currencies have their own benefits, or paper currencies. They are able to price things at a very small level. One second. They're able to even price things and move things at a high velocity, because they are able to have many different transactions. Gold cannot be used as fast as you can use fiat currencies, particularly digitally, which is happening right now. And there is a very low cost for transferring gold. No, sorry, fiat currencies, but not for gold. Transportation of gold is a big barrier. Now, this is what Bitcoin solved. Bitcoin could achieve best of both worlds. It could be divisible to price to the level of fiat or more. There is eight decimal places to Bitcoin, and it can price things at a very granular level. The smallest unit of Bitcoin is called a Satoshi. And it can price things at the most granular level to price even data. It is durable, it is portable, it is maintained by the global ledger system, which is robust, which can't be hacked. It's a highly robust security system also that's functioning with the blockchain technology. It's able to be portable. It's scarce because of the algorithm creating the coins. In fact, that's another homework you have to calculate the number of coins that will come into circulation and by when. It's a geometric progression. It's very easy to calculate. 50 plus 50 plus 50 every 10 minutes for 4 years, then 25, 25, 25. So a geometric progression that converges to a number. So naturally, that many coins will only come into circulation. So it's scarce, it's neutral, it's global, but it's not accepted everywhere. That's a problem. It is neutral, it's global, maintained by different ledgers, but it's not accepted. That's where the adoption of Bitcoin lacks. And that was a real battle to have a lot of adoption happen, but it wasn't adopted successfully. And there's a lot of regulations also that were not supporting its adoption. So national currencies and national central banks compete with Bitcoin. So if they do not accept it, if they do not regulate it and accept it for some form of medium of exchange or to maintain the ledger, then it is not accepted by majority of the players in the economy forming businesses, because they can't be forming or adopting or using something which is unregulated, which creates a bottleneck in adoption. And that's why one of the reasons of why Bitcoin failed to get adopted and get used as the global monetary system is that it was not regulated. And there's where some bottlenecks come in. It is having high velocity in the original version of how Bitcoin was created by the creator. But currently, the popular version of Bitcoin is not fast. It's having a 10-minute block time, and people have to wait for 10 minutes. And there's even more block time involved for having multiple confirmations of transactions in a block to be able to do accept payments. So that's not having high velocity really. But we'll come down to how originally Satoshi, the way he designed it, he didn't have the problem of this. He had an immediate payment system which was global, and he had made sure that the system does not fall the same track as Liberty Reserve and eGold had followed, because they were anonymous systems which cannot be tracked and which were made sure to be made in such a way that certainly the governments would take it down. But Bitcoin is essentially was not made a system like that. It was made as a system which could be regulated and tracked and could be used by governments as a global ledger system, as a very well used system with high velocity of currency and very low cost, just like fiat currencies. The low cost is also a property of Bitcoin that has failed in the current years, which is a popular version of Bitcoin. It's having costs of multiple dollars to pay. You can't do a payment of, let's say, a tea of just a few cents. If you, the cost of transaction itself is multiple dollars. And that was when the scalability requirements were not getting met. We'll come down to the history of why that was, but this is what the Bitcoin vision has been, to achieve a vision of Bitcoin as a global ledger, which can power not just Bitcoin, but even fiat currencies to be represented on the ledger and power a global shared ledger for efficiency of economics, forming, and of economic gain of a data economy at the core. So, this global data economy is there in the name itself of Bitcoin. Bitcoin, in the name itself, is bit plus coin. Bit stands for data, coin stands for money. Bit is the unit of data, right? You have megabits, megabytes, gigabits, gigabytes. They're all units of data. Have you guys heard of the term data is the new oil? Please say in the chat box yes or no. This is a statement used by many machine learning enthusiasts and AI. They all rely on data. Data is the commodity here on the internet. Data is the new oil. And Bitcoin was built on this commodity of data because it's to power a data economy where ledger space to make transactions is the commodity. You're having the commodity of ledger space that's used to add your transactions. There's a demand for ledger space and there's a supply for ledger space. And the ledger is a central ledger that's having tight supply, demand and supply constraints. That's what's giving a price to Bitcoin. Now, this is what powers the global data economy, the vision of a central ledger to maintain the entire global economy. And for that, you just don't need Bitcoin, but you need the entire system of economics where multiple objects are represented on the ledger, national currencies on the ledger, which are known as now central bank digital currencies issued by different governments. Even India has the Indian rupee, the digital rupee getting issued on the blockchain for that. So you have global currencies getting issued on the blockchain. And then you have not just that, you have multiple different objects or financial instruments and different tokens getting sold as tickets or anything else of value getting sold on the shared global ledger and having the efficiency gains unlocked by that. That becomes the protocol of a ledger on the internet, forming the internet layer of protocols. So, this was the vision of Bitcoin. Now, there is an error code associated with HTTP. If you search about it, error code 402, you will find out how it mentioned this code is reserved for future use. It was never implemented because we didn't have a solution for natural payments on the internet. It was written that it's reserved for usage for a micropayment system that will come into the future. Micropayments, what are they? Micropayments stand for payments of amount less than a dollar. So for the internet economy of the data economy, you need a micropayment system because you need to be able to price data, which is going to be priced much less than a dollar in cents, not in even in cents, in micro cents, in micro pesas, and even lower. For the natural data economy to get powered, where every data packet is not just transferring data, but also data in exchange for money by the server. So you're paying the server for some data, and the server is giving you data in exchange. That's what's going to power the protocol of money on the internet for data, the data economy. So micropayments on the internet have been the original purpose of Bitcoin. It's there in the name itself, bit plus coin, as we discussed. If you see the first few sentences of the white paper by Satoshi, commerce on the internet has come to rely almost exclusively on financial institutions serving as trusted third parties to process electronic payments. While the system works well enough for most transactions, it still suffers from the inherent weakness of the trust based model. What is that weakness? Completely non reversible transactions are not really possible since financial institutions cannot avoid mediating disputes because they are made to solve for payments done for objects having higher value. They're not made for objects to have irreversible services like data priced very small, and that's having a broader cost associated with doing payments in a traditional system. So that is putting the minimum practical transaction size to be a lot larger than small data transactions to power the data economy. That's what's creating the barrier to entry and the loss of ability to make non-reversible payments for non-reversible services on the internet, like servers sending you data. With the possibility of reversal, the need for trust spreads, and the need for the payment intermediaries to come in and have a lot of cost associated with the transaction also comes in, and the settlement times also goes high. So that's all gets removed if you have a irreversible payment system. That's the original purpose of Bitcoin, and that's what Web3 is all about. There is a term called Web3, which is the new version of the internet, or the more forward looking version, because we don't have that achieved yet. The forward looking version of the internet that wants a data economy to be achieved between different parties. It's also called the value layer of the internet. As we saw in the protocol layer of the stack, you're not just having currency like Bitcoin there. You're having national currencies, you're having everything of value, anything of value getting transported with this ledger, updating the records of their value exchange happening without the double spend. That's the layer of the ledger on the internet, which becomes the value layer of the internet. We also called Web3 as the MetaNet. MetaNet is a new world of micropayments and data economy where you pay or earn from your own articles, earn from your per minute of video you create, earn from every internet search that you are powering or you are giving the results for, or if you are the user, you pay for the search in a micropayment, and you have the incentive system aligned where Google is incentivized to give you the best results because you are the customer, instead of somebody else being the advertiser who is actually the customer to Google paying for their results to come. So the incentive system get aligned for you to get the best results when you are paying with a micropayment of, let's say, even one paisa for one Google search, and Google might earn the same amount of money with a micropayment system on the internet. The payment is immediate, and the service of Google is also immediate in a single payment transaction of a data packet. That's what is the vision of Web3 or Bitcoin or MetaNet, whatever we call it. Currently, if you see, the entire internet is formed by different distribution networks, right? Google, if you think about it, is a distribution network for links. You search for anything, you get a list of links that are relevant to you. It's distributing links. YouTube, you search anything, you get a YouTube list of videos. So it's a distribution network for videos. Twitter is a distribution network for tweets. Like that, you have distribution network. Instagram is a distribution network for photos. If you want your photos to be broadcasted to somebody you don't know, you pay for it. You have more distribution because there is one central entity, which is a private player, who is controlling the distribution. They have the maximum access. They will give you distribution if you pay for it. And if they don't like you or want your solution or your product or your service or your content to be distributed, they will not distribute it. So there is the difference here where we are having a monopoly created on the internet by different players having control over distribution, because the nature of the internet is such that we are getting connected and different players are getting connected, and it's the nature to get a social network formed for parties to be connected to each other. And if the connection is going to be made centrally, then you can only have a central distribution network that's going to be controlled by one entity. The same problem that existed with our problem with the ledger, where there was only one central ledger. So this is what's happening, and that's getting solved with the Web3 economy. Now, there are different tokens created along with Bitcoin. Not just Bitcoin getting represented, but real world objects also represented, which is called as the process of tokenization. You can track objects on the supply chain as well, which is forming on the ledger itself. You can have a content economy form with different financial models to power the data economy, where digital rights management of content is happening with the ledger as well. Those are the different use cases which will inspire you to build different solutions at the end of this program. So this is why the program which we are having right now is going to teach you not just the coding and development part, but also why it is really important to be having the vision of a globally shared ledger achieved, and how you can contribute your own part by developing applications on this shared global ledger. If you're having any doubts, let me just go over the comment section and check out if you're having any questions we can answer. So this one is going to be a long session. It's going to last an hour more because there's a lot of topics that need to be covered, and you can watch it at your own pace as well, and make sure you can achieve the entire session and have the attendance marked for it as well. You can learn everything you need to learn. Plethora of blockchain solutions. Have you heard of different blockchains like Ethereum, Solana, Polygon, EOS? If you have, type yes in the chat box. So why are there so many blockchains existing? Why so many blockchains? Can somebody answer? I want to see the answers in the chat box. All have their own consensus theorem? Well, yes, that is true. That's one reason. Anybody else? Just improvements. Scalability, yes, very important point. That's a good answer as well. Each having consensus mechanism, yes. Each block chain is a different protocol. Well, yes, the different consensus system, all having different security levels and applications, better than other blockchains. Scaling, yes. Diverse use cases, pretty much you guys have hit all of the points. So let's summarize all the things. You have my comments. Why so many blockchains? First important point is scalability, right? Some blockchains are not having the same scalability like other blockchains. So different blockchains are competing to be able to have scalable ledger globally. Capabilities. Some blockchains, well, this was not mentioned by anyone, if I checked out the comments correctly. Some blockchains do not have smart contracts. Some blockchains do have smart contracts. That's the ability to do conditional payments. Some blockchains are made for specific use cases. This was mentioned also by someone. You require blockchains to be general purpose. If ideally you have a general purpose blockchain in which you can develop any type of use case, that would be a general purpose public blockchain. But then there are different blockchains, just like there are different products in the market also. Some are general, you can do anything with it. Some are specific. Some smartphones are made for specific sizes, specific requirements. Like that, you have specific use cases. Some blockchain exist for only, let's say, for telecom. There is a blockchain for telecommunications only. There's a blockchain for only tokens to be issued. Financial, fintech solution blockchains. There are different use cases that have different ledgers, different blockchains competing. You have control. So there is different types of consensus algorithm mentioned by different people that is existing today in different blockchains. That's how you have different blockchains also. Not all of them are using the same system of a free market competition for blocks like is happening in Bitcoin with the proof of work system, but rather there is more voting type of systems instead of a market-based system, which makes a proof of stake blockchains. There is different types of other systems as well, which get consensus without having the way done by Bitcoin as proof of work. So that's different ways of control. There is permissioned blockchains as well, where not anybody can participate to make the ledger. Just like the Bitcoin protocol or the other public blockchain networks, you can have any node join in and create a block if they satisfy the consensus mechanism rules. But controlled blockchains like Hyperledger and others, they have permissions involved to create a block. You have authorized nodes only they can create a block. They can add to the transaction. Now, the consensus mechanism determines who is going to create the next block. In Bitcoin's case, it's anybody who solves the puzzle, the hash puzzle, which is proof of work. In proof of stake, there is a model in which you stake your coins to vote for who is going to be the next leader, who's going to be the next block producer. And that's determined by staking your coins. That creates its own incentive system that we can discuss sometime later. That is his own problems and his own benefits as well. Competition is the last reason why we have so many blockchains. Competition is, even if you have, let's say, the most scalable blockchain which has all the capabilities that, like, let's say, having a Turing complete system that can do everything for a particular use case. Just a second, guys, let's take a pause. Manish, attendance will be given at around in the middle of the session. We'll be spreading a link that will be used for the attendance, but focus on the learning right now, because this will be used to issue the certificates. Competition. Even if you have different blockchains, you still require, or at least have, different blockchains competing. Just like if you have the perfect smartphone or almost the perfect smartphone, if it is fully commoditized, if you have a fully scalable blockchain, even with multiple capabilities, it can do Turing complete smart contracts. It can satisfy the general purpose use case in which you can build any use case. You can have controlled subledgers also to have permissioned cases. You can have fully public control as well. You can control your data. It can satisfy all the requirements, but still there is different brands competing just because there is a market share involved with getting blockchain adoption. So there is a competition to have globally shared ledger by different brands. That's why different chains also exist. So history of blockchain scaling solutions. Let's first focus on the scaling debate. The scalability has been a very important point for blockchains to be adopted, because till 2014 or 15, when Bitcoin was getting used as the payment system between small number of players, it wasn't really a problem because the transaction fees were too low. It was in a few cents, not even a few cents, less than a cent. And there was no problem. The transactions were immediate. But then the transactions cost started increasing. Why? Because in 2017, there was a huge influx of people that joined, particularly around 2016 to 2017. The price of Bitcoin also shot up from about $1,000 to $20,000 in a span of just 1 year. And that's what created a huge demand on the ledger, while the supply was constrained at 1 MB only. So the block size limitation was enforced by the protocol of Bitcoin to 1 MB limit. So if in 10 minutes you can have only 1 MB block size and you can fit the whole world's transaction in those 10 minutes in only 1 MB, then you will have a supply constraint of how many transactions can go through in those 10 minutes, because each transaction also has a fixed minimum size. Mostly it's larger if you have more outputs in the transaction. So that's what constrained the transactions per second of the blockchain of Bitcoin. Same problem exists till date with Ethereum as well. The block size constraint cannot fit a lot of transactions. So the scalability constraints cannot be met on the layer one. So that's where the blockchain has scalability constraint. And there is different blockchains that came into the picture to solve the scalability problem. And even within Bitcoin itself, there was a huge debate in the technical community of Bitcoin to have the scalability problem solved. There was a civil war that happened of Bitcoin that diverged the network into Bitcoin Core, known as BTC, currently the most priced Bitcoin, which restricted the block size at 1 MB only and did not increase the block size. So it could not increase in capacity at the layer 1, at the blockchain layer itself. There is a community and a fork of Bitcoin that formed after the civil wars of Bitcoin, that's also known as the Bitcoin Satoshi vision, that did increase the block size and removed all limitations that were placed to the Bitcoin protocol and the ledger after Satoshi left to improve the scalability of the Bitcoin blockchain. And that is another coin in the market, also known as Bitcoin Satoshi Vision, BSV. There is another coin also on the same. There is multiple different forks of Bitcoin. By a fork, we mean there is two types of fork that happen. There is a hard fork and there is a soft fork. A hard fork is where it's not just a software update accepted by all miners of the protocol, but there is actually a hard fork in which the protocol is changed such that miners are not accepting the protocol change and some miners are accepting the protocol change. So it's not just a software update, and it's the transactions, the blocks get diverged. Some miners support one side of the chain in which there is no update, and some miners support another side of the protocol in which there is an update. That's what diverged the ledger and the community and the coins and the market to create different Bitcoin versions to solve the scalability problem. So Bitcoin Satoshi Vision currently has no block size limits. Bitcoin Cash has limits of about 50 MB, around that number. Bitcoin Core has only 1 MB limit on the main chain, probably increased to 2 MB later on. And that's what creates the limitation in the Bitcoin Core transaction capacity fees as well, because the fees start getting more if multiple people try to bid their way into the block. So the fees also go high. So the fees, along with the scalability constraint, the fees for making transactions started going high in 2017 to make a transaction. And that's what is solved when you have a scalable block size. Now, there is another strategy to scale also. So this is essentially the Bitcoin history of the scaling debates. So there was the big block size debates that happened. Stable coins came into the picture. What is a stable coin? Stable coin is a token represented on the blockchain, issued on the blockchain by an entity having equivalent number of coins of real world currency. So they're representing one to one a real world currency like rupees or like dollars or other currencies on the blockchain. They have real bank account money and they are issuing the equivalent amount on the Bitcoin blockchain or any blockchain for that matter. That's what creates the stable coins. So stable coins were launched first on Ethereum blockchain, and that's what powered a lot of the influx of many people and the surge in demand in 2017 of the blockchain and the coins. And then there were different blockchains solving for scalability. One strategy to solve has been to do layer 2 solutions instead of layer 1 scaling. Layer 2 solutions use different consensus mechanism in many cases, but consensus mechanism do not affect scaling because the block size, if it is still constrained, it does not affect how you're choosing the leader for the next block. The block size is still constrained. So that's a misconception also that's very prevalent, that proof of stake solves scaling. It does not solve scaling. It does solve the problems of cost of transactions said to be there with energy inefficiency of Bitcoin as it is touted to be. We'll talk about it also of if that is true or not, really. So proof of stake blockchains also came into the picture to solve some of the problems that existed with proof of work systems. So there are layer 2 solutions also that came into the picture. So that's what the different scaling strategies involve. At layer 1, we are talking about the blockchain itself with the block size getting scaled. So you have a scalable block size in the blockchain and you can adjust for any number of transactions. That's layer 1 scaling. In layer 2 scaling, you have, well, you don't use the blockchain at all. You use a private ledger maintained between different parties to make different transactions, and you settle periodically on the main ledger. That's what essentially creates a layer 2 system. But a layer 1 is still not scaling. That's when you need a layer 2 system. So most solutions like Polygon and others are there in the system solving layer 2 scaling, not on layer 1. Layer 2 has its own problems that gets associated with it, more security problems, that it does not inherit the same benefits that a blockchain has because essentially it's not using the blockchain at all at the layer 2, and only layer 1 part of it has the security benefits of the blockchain. The consensus mechanism itself has different constraints. You have proof of stake, which creates a different system which was introduced with the first set of blockchains like BitShares and EOS and Steemit. All of these were the first versions of blockchains that came up with the proof of stake system of scalability solutions. EOS was the very first one among them, doing still date the biggest ICO, doing a more than $1 billion of ICO value raised to create a blockchain that can do proof of, that can have a scalable Turing complete smart contract blockchain system. This got developed further, and now you have many different blockchains trying to do many different consensus mechanisms in different ways to essentially get a centralized ledger with a distributed consensus. So centralization versus decentralization also becomes a debating point when it comes to scaling strategies, because it's a central ledger, but you're having distributed maintainers of it. You're having multiple maintainers of it. So how many maintainers is the question. If you have one maintainer, it's fully centralized. If you have 10 maintainers, well, it's decentralized. But how many maintainers is what is going to increase the decentralization. So it's a spectrum. So many in the community believe that, and in the proponents of the protocol, that you need to have as much decentralization as possible, till the level of your Raspberry Pi or your mobile also running the Bitcoin software, which is powering the whole global ledger, which is infeasible in most cases if you analyze this in a perspective that if the blockchain has to be scalable, if the ledger has to be scalable, there will be professional server farms forming, which will create professional companies. There will be multiple companies. It will not be centralized because they'll be processing gigabyte size blocks, terabyte size blocks, a huge block competition, just like you have data centers forming naturally as different companies competing on the internet to form the data economy currently without a ledger or the layer of value on the internet. The server farms also essentially act as data centers that compete, and there is enough decentralization with data centers of 10,000 plus in number globally. That is the debate on centralization versus decentralization. Permissioned blockchains is another way of scaling where you centralize the blockchain in such a way that you're having selected miners or selected players only able to create the blocks, and you have a central server essentially, or a distributed database system, just like your Discord server essentially, or any other distributed database that powers Facebook, like Scala. There is Scala based systems. There is different database sys like Cassandra, particularly used by Facebook, and Discord before that scale. So permission blockchains essentially act as immutable distributed databases, no different than that try to scale. So Bitcoin, but originally could do something that solves the blockchain trilemma. Anybody who knows what a blockchain trilemma is, please answer in the chat box. What is the blockchain trilemma? Vivek, BSV is Bitcoin Satoshi Vision, not Bitcoin Cash. Mukul, the session has been extended so that we can make sure that the most information is conveyed in this session while we go into the practical session after that. And there won't be any theory session involved then. That's a very good answer, Aman. The blockchain trilemma is the idea that it's difficult to optimize all three of blockchain technology's most important aspects at the same time: security, scalability, and decentralization. So that's how it is. But there is a discrepancy here. The blockchain trilemma doesn't solve everything. This is what Bitcoin was made to solve. There is a misconception that the trilemma exists. The Bitcoin network, the way it was created originally by Satoshi, that's why also called the Bitcoin Satoshi vision, that supports the original vision of the protocol without any changes, the protocol that's continuing from 2009, that does solve the blockchain dilemma if we let go of the assumption that decentralization has to be till the level of every single computer on the internet or every single mobile phone also running the entire ledger. If we have professional server farms forming and enough decentralization with professionalism happening, you have the capacity to solve the blockchain trilemma, particularly because of the concept known as mandala networks. This is a topic for people who are into research, also to research, and even part of their thesis, let's say, to research how mandala networks work. There are scale-free networks that have scale-free properties. They're not restricted by scale. And Bitcoin network shows the properties of that of a mandala network. I won't go that much into it and speed up the session. But due to the hyperconnectivity between miners, that every node is connected to every other node, it's a hyperconnected mandala network that is not a mesh network. A mesh network is not scalable. And those are concepts that you can study more detail in computer science. There is research papers written on to it that I recommend you study as well. So the property of a mandala network, which is very useful, is that you have a transaction propagating from a miner the moment he hears it to any other miner in less than 2 hops. So it makes a hyper-connected system where every node is connected to every other node, and transactions are broadcasted within a few hops, less than 2 hops. That makes it very fast network where you can have high transaction confirmation speeds as well, because maximum hash power has already accepted the transaction and you don't need to wait, and it scales because there is no scalability constraints on the block size, and there is no restrictions that you need to have on the transaction size or the transaction capabilities. So that's what creates a scalable system. So the scalability debate started with Bitcoin having 7 transactions per second. Ethereum today has about 14 transactions per second, even with proof of stake consensus mechanism change. The Visa network, which is the card network for payments, processes about 2,000 transactions per second. At a peak capacity, it has the capacity to do 56,000 transactions per second. UPI network also today, with all the transactions that you do daily, has about 2,000 transactions per second capacity. Not capacity, but average transactions happening daily per second. Capacity is again about 60,000 transactions like Visa. But a truly decentralized system with having distributed ledgers can scale just like email scales, and you don't have just one email server. Like that, you have multiple ledgers. The way Satoshi designed it can scale to terabyte size blocks, and it can do million transactions per second, which has been demonstrated even over the past year, of how the original protocol itself can solve the scalability problems the way Satoshi geniusly designed it. So there has been a very broad history for the Bitcoin. There has been multiple wars, civil wars for the paper, or to achieve the vision of how Satoshi designed it. And with the Terranode upgrade of the latest software on the Bitcoin Satoshi Vision network, there has been an emphasis on achieving the vision of Satoshi. Bitcoin Cash and Bitcoin Core and many other versions of Bitcoin also exist, following different protocols that have diverged from how Satoshi designed it. Satoshi Nakamoto, in his own statements, has said that the existing Visa card credit card network processes about 15 million internet transactions purchases daily per day worldwide, but Bitcoin can already scale much larger than that with existing hardware for a fraction of the cost. It never really hits a scale ceiling. That is very contradictory to the opinions of most people in the cryptocurrency space that do not believe blockchains can scale, and blockchains have a scalability constraint, that there is a blockchain trilemma as well. If you're interested, I can go over the ways it would cope with extreme size, also said by Satoshi Nakamoto in his own words. It's very simple. If you restrict the email protocol to have only 1 MB of emails globally in 10 minutes, obviously the email protocol will also not scale, even though it's made as a peer-to-peer scalable distributed protocol. This is exactly what has happened with Bitcoin Core in its original form as well, and now restored by BSV. Today, but we have the internet forming with email being the central point of contact and even an identity system where 2.4 billion emails per second are happening globally. We need that kind of a scale to be having the vision of Web3 achieved. So when the chain forked from 2018, there has been world record blocks that have been forming of 2 gigabyte size, 4 gigabyte size in size, and it has now gone on with soon terabyte size blocks coming onto the network to power the ledger that can support the internet economy as per the vision of a data economy, which we talked about. Because you need millions of transactions per second to power the data economy, which we're talking about. 14 transactions per second is not going to cut it. So the big blockers community in India also exists for this purpose. It's for the big block version of Bitcoin, the version of Bitcoin that scales, that can do smart contracts, that can do low cost transactions, that can do immediate instant transactions. And that's what forms the big blockers community who believe in the big blockers vision of a Bitcoin. So there is competition. There is competition to become the globally shared ledger between different blockchains. There is blockchains like Ethereum, like Polygon, like Hyperledger, like Tron, and many others that exist that are competing with Bitcoin to become the globally shared ledger. Because in the end, just like the internet, there is one public internet with multiple intranets or sub intranets of your college network or your office network, which are firewalled, that exist. Just like that, the most connected system naturally becomes the public internet, the network of networks. Like that, the blockchain of blockchains, the global public blockchain, is going to be the ledger, a shared global ledger, And there's going to be multiple subledgers which are controlled and restricted, just like university internet is restricted. So this is very similar to how we had a protocol war that happened when there was no established protocol for the internet. There was no internet protocol, IPv4, which we know currently. There was no IP protocol, so there were ARPANET and many other nets by different private players competing to become the internet protocol globally. This happened in the 90s, till the 70s to the 90s. And finally, it was settled by the US Department of Defense coming and launching the internet protocol. And this is a similar thing that's essentially expected to be happening on the blockchain ecosystem as well, where there's going to be some standards that are going to develop after the internet OSI wars. Going ahead, the great crypto bubble. It's what has happened right now. There is multiple cryptocurrencies that are competing, and there is a lot of speculative investments not grounded in utility, which are replicating what happened in the dot-com bubble. So there is the dot-com bubble that happened in 2000 with the protocol war that also happened right in the 90s. There were every business coming up with their own domains, and just because domains were getting bought, people were investing into the businesses without a proper business model. And that is the same thing happening in the great crypto bubble. And the dot-com bubble crashed, and then finally you had real businesses like Google's and Amazon's of the world form after the dot-com bubble. But there were many businesses getting invested with a lot of speculation happening. And that's the same thing happening right now, which we call the great crypto bubble, which is also in a speculative state of investments, which will only subside when there is a proper regulation as well as proper standardization of how the ledger systems of the internet is going to work. So this is where the multiple blockchains competing versus a shared ledger technology globally comes in. You have the benefit of a shared ledger only when you have a ledger that's shared in the first place, that's connected, and that's not multiple different ledgers which are disconnected as multiple blockchains. So this concept of the globally shared ledger is what we are going to achieve together in the course of this journey. There are different types of blockchain that you need to know from a theoretical standpoint. There are public blockchains like Bitcoin, Ethereum, Solana, Polygon, and many others. There is permissioned blockchains like Hyperledger. There is hybrid blockchains that are now coming into the picture, which can do permissioned blockchains with the benefit of public blockchains as well. In Bitcoin, we do it as, by Bitcoin, I mean BSV, we do it as overlay networks on the Bitcoin protocol. There is different ways that it is done in different blockchains. Here is the link that many people were asking for the attendance. You can scan this and mark your attendance by filling the form present at this link. I'll give you a few seconds and answer some of the questions while you are marking your attendance. Yes, Vivek, it can do. Yeah, Bitcoin Core can only do Bitcoin transactions of only 7 transactions, but that's Bitcoin Core. There is one known as Bitcoin Cash, which can do a lot more, and Bitcoin SV, which has demonstrated to do millions. 1 million transactions per second is achievable with the original protocol as well. Okay, let's continue then. So there is a Watson chain explorer for the Bitcoin blockchain, particularly the BSV blockchain. Like that, every blockchain has their own explorers. What is an explorer? You know, Internet Explorer was formed as a browser system to browse the internet when the internet came. Just like that, the ledgers have come, and there is a system or a products that have come out that provide the software for you to browse the ledger transactions, browse the transactions on the ledger, right? So when you make a wallet and you make a transaction also, they are visible on the ledger. So if you can see my screen, I think there would be some discrepancy there. I'll have to share another screen. Yes, now you'll be able to see my screen. Yes, so this is how Blockchain Explorer looks like. It's very important for you to understand to get little visibility on how to go about using the Blockchain Explorer and understanding what it is. So there is a list of blocks. That's the most important. It has serial number 8408026272829303132. This is the latest block, which is the block height, created by a miner called Cub. There is Tal doing multiple transactions, multiple blocks. There is QD Link doing a block. Like that, there are different miners competing to create different blocks. And this is the latest block on the blockchain. There are different blocks there. You can search for a transaction ID, a block height, an address, which is your wallet address, to get transactions. Now there is the list of blocks. 84032 is the latest block. Then you have more blocks going ahead. If you go back through the chain, if you go to the Genesis block, which is the first block till the back of the chain, you will get the very first block, which is of block height 1. If you see block number 1, this had the Genesis transaction, only one transaction inside it. That's how the Bitcoin blockchain started. If you see the timestamp, it was 2009, 9th January. If you see what was there inside it, there were newly minted coins. So the first transaction of every block is always a coin-based transaction. A coin-based transaction means the first transaction where new coins, newly minted coins come into the circulation. I'll show you how a normal transaction also looks like and how it is different from a first transaction, which is a coin-based transaction. So that's the first block. Just a second, guys. I have to show you another block as well. Okay, continuing on this. So we have the first block. Let's look at, let's say, the 1000th block, right? You'll get to know how transactions have started on the blockchain. It's still having one transaction. Let's go to 1 lakh, no, 10,000. It's still one transaction. So for a long time, there was no transactions happening on the Bitcoin blockchain. And slowly you started having some people making transactions. See, when I have come to block number 100,000, 1 lakh, I have got 4 transactions in it. This is the Coinbase transaction. This are normal transactions. Let's say we go into a normal transaction. How does a transaction look like? It's important to know. It's very simple. It's having inputs and it's having outputs. So you have inputs of 3 Bitcoins and you have outputs of also 3 Bitcoins. So since inputs is equal to outputs, there is no difference. So there is no transaction fee getting paid to the miner. And there is 2 outputs created adding up to 3 Bitcoins. Let's say 0.01 plus 2.99 adds up to 3. So if you are the person holding 3 Bitcoins and you are transferring, you want to transfer to somebody, having somebody do a payment of 0.01, you create an output of 0.01 paying to their address and you get the change back, your own output, paying to yourself, your own address, 2.99. So that's how a cash system works. This is very different fundamentally from an account based system. which happens in Ethereum and banking system already. An account based system has a balance, right? You have a balance that's maintained as a single number, which is a state, and you don't have different outputs of cash. Your wallet is a cash system. A cash system has different notes and different coins that are there, and that can be individually given out and that have an individual history. You receive one note of cash, let's say 10 days before, another note of cash 20 days before. You start to use one note of cash in one transaction today. So the entire balance is, there is no particular balance as one number maintained in your wallet somewhere. If you need to calculate the balance, you can calculate by adding the outputs you are holding or the notes and coins you're holding, which you can unlock and you can spend in a transaction. But there's no balance as such. When you have an account based system, the balance gets updated sequentially. So you have a limitation on scalability there, because the balance can be updated in a sequence only. It can be updated linearly. Let's say I do a transaction, then only the next transaction somebody pays to me. It has to be important that the sequence is valid, because otherwise I'll go into negative by mistake if the transaction that somebody I try to pay first what I didn't even receive. So there's discrepancies that start happening. So you need to have a linear transaction system to update the balance when it's an account based system. But when it's a cash based system, you have independent processing of each note of cash. Each note of cash can be independently processed. Has its own history, so it can scale indefinitely without needing processing limitation that it has to be processed linearly. So that's a very good system created by Satoshi, also called as, these outputs here are also called as unspent transaction outputs. Though this is right now not unspent, because you can see here it was spent in a future transaction as input number one. So it got spent, but when you pay to someone and it's not spent yet, the bitcoins are held in unspent transaction outputs, also called as UTXOs. So this is the crux. If you need to understand this at its core, make sure you rewind and go through it again, because this has been the core of understanding a blockchain. We'll deep dive into the technical part of the theory as well. But essentially, you have the blocks have the list of transactions. If we go into one of the latest blocks, you have a list of transactions getting created by different applications. Time of TX, Certihash, all of these are different applications, real world applications creating different transactions. And each of those transactions, let's go to a non-standard transaction. It's having one input, one output, but there is a discrepancy in the output. Output is lesser than the input, right? So the difference is actually the mining fee that has gone to the mine for this block. And then there is the scripts also. We'll come to the smart contracts part of it as well, of how you can do a non-standard custom script instead of the standard Bitcoin payment. And that's how you can have a conditional smart contract written on Bitcoin. That was always there with the Bitcoin protocol. So there is a wiki for you to understand how the protocol works. And those of you who have done the certification course that has been shared with you, which is the Bitcoin script certification course, will be able to learn the Bitcoin virtual machine, the BVM, having their own scripting language of how this scripting works. It has an operations code list, which you can also find here by searching OP codes. You will get the operation codes that are there, which is the assembly level codes. You don't need to understand it really, but if you fully understand this, you'll be able to understand the Turing completeness of how to write smart contracts. Because when we try to build applications, well, 90% of the applications can be done without knowing smart contracts or having to do custom smart contracts, because you already have contracts written for you. The standard contract is the locking script that transfers a Bitcoin. Then you can have multi-signature transactions as well. And like that, you can go on to have creations of your own custom scripts, locking scripts also, which lock and hold the coins. We'll come to that in the sessions. Day after tomorrow, the third session, we'll go into smart contracting as well Tomorrow we'll be actually creating a transaction. Today we'll be finishing for you to actually know the theory fully, for you to understand what is happening with the blockchain and transactions in it. So this is a section from the white paper itself. This is the ledger. You have the transactions happening by the signatures. This is the most important part. The signatures are what is transferring and getting verified for the verification of the transaction. And the time-stamped append only ledger is formed by different blocks, and each block has a block header. The block header is connected to the previous block header by referencing the previous block hash. This is a hash system. You need to understand hashes first in cryptography. For you need to appreciate how hashes work for you to fully understand how the system is working. It's a very simple concept. If you pay a little bit of attention and process it entirely yourself, you'll be able to understand how it is working. A hash is an algorithm or a function that takes in any input of any size and creates a fixed length output. And there are different algorithms that create different lengths of hashes. So SHA-256 is one type of function or one type of hash which creates a 256-bit output. Now, what is that? It's hashing the message or whatever data you have and creating a fingerprint of it. A fingerprint, you can say a digital fingerprint, with which you can identify the data. So if you change the data, you will change the hash because the function makes sure that it changes and you have a different hash for a different data. So with just verifying the fingerprint, you can verify the whole data, whatever you have received, it is authentic, is exactly what was shared or not. So whenever you download something also, there is a hash shared with you. Even let's say you do a torrent or many other things, download a library or a GitHub repo, you get a hash. And that hash is matched automatically behind the scene, that whether what you downloaded is exactly what was uploaded and what was signed by the issuer with their own keys. So exactly that type of system is what is happening on the ledger as well. Now, if you want to maintain the integrity of the ledger across different ledgers maintained by different people, how do you ensure the integrity of the ledger? You are going to have one global hash that can represent everything, one fingerprint for the entire ledger. And if you have the latest block's fingerprint connected with all the previous block through a hash chain, by hashing the previous block and having the hash of the current block, the fingerprint of the current block as well, and you hash all of them together, so you have the fingerprint that can represent everything that has happened till now uniquely. And that's the power of hashing. And it can scale indefinitely because the size of the message that needs to be hashed is unlimited. You can keep hashing, you can keep joining multiple hash, then creating a hash of that. That's what is creating a concept known as Merkle tree. So Merkle tree is a hash of hash of hash of hash, a tree of hashes, which is binary data tree with hashes. So all the transactions that are there happening in those 10 minutes are the data points in the leaf of the tree as data 0, data 1, data 2. These are all transactions that are there happening as part of a block. A block is simply listing all the transactions that happened in those 10 minutes. Then the hash root hash is calculated. How that is calculated is by having hash of each transaction. Then you combine the hashes and you get more higher level hashes. And finally, you get to the root hash. That's going to represent the entire block. So it's going to be the representative fingerprint for this entire block of what happened in those 10 minutes, right? So that's what creates the root hash. Then you combine the root hash. This was a concept used in Hashcash as well, the email system created by Adam Back, in which spam was reduced. In that the email itself which you are sending is hashed, the message is hashed, and then you are doing a proof of work attached with it. So exactly that's what we are doing. We are getting all the list of transactions which we want to add in a block. We are creating the block proposal in which we are adding a block header. The block header is going to have the hash of the previous block the transactions hash, the current hash of the Merkle root, the Merkle root of the current block, and then it's going to have a timestamp, the timestamp of the current time which we are producing the block, which is the Linux timestamp. And then there is an unknown value, which is the proof of work difficulty number that the miners are iterating through a random number to find out which number is going to, when combined with all of these as a string, and the entire thing to be hashed, entire string combining this, the previous hash, the current Merkle root, the timestamp, and this random value, the entire hash of this string to be equal to a string, which is the block hash, this unique block hash that's representing the blockchain at that moment of time. That block hash is going to have a difficulty of number of zeros that need to be there in the beginning of the hash, which is calculated. So if there is multiple zeros, but then there is a one before the difficulty number, a one comes, then you need to iterate, keep iterating and finding by brute force the nonce value, which is going to give you the correct difficulty constraint number, which will be a valid block. That's how we prevent spam on the blockchain network. Spam gets reduced just like email hashcash system reduced spam, because not everybody can just create a block and create fake double spend problems and try to diverge the network into multiple chains. So there's enough difficulty to make sure you're having a longest chain and enough incentive system so that you are converging on a single chain. That's what is creating the centralized ledger system, which is also decentralized in different miners holding it. So retrying with different nonce gives you a new digest, which keeps going on and on. And this keeps continuing and you keep going again and again in the next round. That's what continues the blockchain. So if you understand this diagram, which is the block header, which has the previous hash, it has a Merkle root, it has the nonce value, it has one thing not mentioned, which is the timestamp, but all of this is hashed and it creates the block hash. And if you see, this gets continued and attached, and if you see the Merkle root, it's having hash 1, hash 2 3, which is combination of hash 2 and 3, transaction 3 here. The transaction 3 here is having a branch which is called the Merkle path. Merkle path is uniquely representing the transaction and how it's having its own proof with its Merkle path that it is part of the actual blockchain currently. Because it's, if you have the list of block headers, let's say you have the list of block headers and you don't have all these transactions with yourself, but you only have this transaction, your own transaction which you sent, you can prove that it is part of an unspent transaction by giving the Merkle branch or Merkle path for this transaction that you own also. And that's all your wallet needs to keep. So that's what your wallet maintains. Your wallet, which follows the method laid out by Satoshi, which is called simplified payment verification, with which blockchain wallets can scale again, is having a system in which the Merkle path is maintained by the wallets, block header is maintained by the wallets, and then the transaction is sent peer to peer to another wallet, and they are going to receive the transaction and they are going to broadcast it on the blockchain. So there is a very important point happening later on when we discuss SPV in more detail, simplified payment verification, we'll come across it. But this is not done by any blockchain other than Bitcoin Satoshi vision. Even though Satoshi laid out it in the white paper of how it is supposed to function, there was a lot of technical debt associated with Bitcoin of why this was not implemented by Satoshi. There was a lot of implementation protocol iterations that needed to happen for you to achieve that. So the ecosystem had to develop, and right now we have got the implementation of this already. But this is something that's required for you to achieve a scalable blockchain infrastructure. Very simply, I'll tell you why that is the case. Right now, how most blockchains function and how most wallets function is you have a wallet, which is, let's say, your Ethereum wallet or your Bitcoin Core wallet, BTC wallet. You make a transaction and you broadcast it directly to the miner, to that address, to the other wallet address. And the other wallet address has to keep scanning the entire blockchain for their own transaction. whether they receive the transaction or not. That's like you have one centralized email server, and everybody has to contact that server and go through every single email that comes sent to the entire world, go through every single email, the stack of email, to figure out where their email is. And that's how that creates a bottleneck. If you scale the block size, that works when you have only 100 transactions or a few 100 transactions, 1000 transactions happening in a block. But when you have terabyte sized blocks, huge number of blocks, the entire internet running on the blockchain, you need a system in which you can prove that your transaction was part of the block and you are receiving the transaction directly without your transaction being fetched, and you are having to, your wallet having to see the entire list of transactions and verifying whether your address is the one that's the current transaction or not, which is not scalable. So a much more efficient way was laid out by Satoshi as well, and that also works out very, very well. So the payment in the SPV system does not happen from A to miner, then miner, every transaction of the miner, the B wallet is reading, but rather it happens A to B directly, peer to peer, as envisioned by Satoshi. And then the B, who is me, who, let's say, who has received the transaction, I am having the burden, you can say, of adding the transaction to the ledger to the miner. So A to B to M, the miner, is what the transaction flow happens in an SPV wallet. So I get a SPV proof also from A, the Merkle branch of the transaction, showing that it's an unspent transaction. And I verify it with the miners and I broadcast the transaction because I am concerned that I am getting paid or not, or I am getting scammed with a double spend attack. So that's what creates the SPV system. So I broadcast it to the miners and I get a proof in return, and I confirm the transaction with the proof of it getting added on the ledger back to the sender of the payment. That's the SPV transaction flow of how a wallet functions. Now, what is a wallet itself is something we will also understand. It's very simple. It's a key system. It's a key pair. A key pair, that is the ECDSA key pair. Elliptic curve cryptography is one of the ways of generating cryptographic keys. In Bitcoin, we use the elliptic curve for generating the keys, and different keys are generated for different transactions to maintain the privacy, which is also something Satoshi said, that to maintain privacy of the blockchain or your users, you need to have new addresses generated for every transaction. That is done in the protocol of Bitcoin Satoshi Vision. For that, you require a different key system to be generating new keys every time you have a new transaction, new ECDSA key pair. Now, what are the key going to do? They're going to sign the transactions. And the transactions are very simple. They are just signing your wallet inputs and spending them, giving the correct answer to the inputs to unlock your Bitcoin holdings, which are held in different UTXOs. You unlock them with your signature and you spend them as a new output. That's how you create a transaction and broadcast a transaction. So UTXO is the most important term that we want to convey as part of this session. You can understand is, if you understand this, you will be able to understand where the bitcoins are actually held, because all the current bitcoins in holding of or any coin which is based out of UTXO model with scales is always held in the current UTXO set, which is a minor set. It's a small set of uh, outputs that are currently not spent, unspent transaction outputs that are holding all the world's bitcoins, you can say. And miners maintain this list and try to see which transaction is coming and which transaction is spending which output. So they remove from the UTXO set which output got spent. Wallets do the same thing. Your wallet literally, physically also, your wallet does the same thing. It has a list of outputs or list of notes and coins. You spend, you reduce the set of outputs you are holding, and when you receive, you add to the set what you're holding. That's what the function of a wallet is, and that's what globally the miners are also doing. They're maintaining the UTXO set and they're updating the UTXO set with new transactions happening, and the ledger keeps forming. Archival nodes keep maintaining the entire history of the ledger, who are specializations that maintain the history of the ledger, entirely. But the function of the miner at its core is to produce new blocks by adding new transactions, by verifying transactions, proposing new blocks on the blockchain. And a miner who does not produce a block, who is just serving the network as other services, is not a core node of the system. It's a service provider for that another node that's acting on the system. So this diagram here shows you everything you need to understand what is happening in one go. There is the blockchain connected by the chain of hashes. There is the Merkle path, and Merkle root is there at the top where you have the block header. The Merkle transaction is there, which is making the leaf of the tree, and each transaction which is making the leaf of the tree in the Merkle tree, there is going to be inputs and outputs in those transactions. A transaction in the future sometime, when you spend your output you have received, let's say you have received transaction number 2, where output number 1, v out 1, is your output. You have received this, your address received this. There's a locking script maintaining this output, and you are trying to unlock it by giving the correct signature in the next transaction you are making yourself. You are spending your coins by adding it as input and spending it and creating a new output. So this is how a digital cash system of Bitcoin is designed, and that's how that works. So there are different locking scripts that can hold the coins. So there is the standard script, which is holding the coins, in which you don't have to write any smart contract. There are 5 standard scripts given by default, which is pay to public key hash, pay to public key. Pay to public key is just basically you're paying a standard transaction. Like that, you have multi-sig transactions also, in which you can have multiple signatures needed to unlock a transaction. So let's say you have joint accounts in banking also, right? You can maintain joint accounts. So multiple signatures need to come in order to unlock your coins. That is also possible. Like that, you can write your own smart contract also by understanding this, either the scripting language, which is called custom scripts or custom locking scripts. So this is written by you to hold your coins or send it to someone and have a custom script written that they can unlock it only when they have the correct answer for that function. So that's what a smart contract is, a conditional payment of some sorts, in which you hold or lock your coins in such a way that they can't be unlocked until the correct criteria are satisfied. You can even write problem statements, even write puzzles there as functions. Let's say somebody who gives me the square root of 2 up till 5 decimal places is able to unlock the coins. Unlock, let's say, 2 bitcoins for bounty. They can unlock the coins if they give me the answer of 2 up till 5 decimal places. That's a custom smart contract, a custom script that will get unlocked with the correct answer for this. And that's what you will get to learn in next session. Next session, we will deploy a transaction, a standard transaction. We'll create a wallet, create a transaction, broadcast a transaction, view it on the blockchain. Guys, were you able to see my screen of what's on chain, or were you seeing my screen of the slides right now? That is a problem. Okay, let me bring up this screen again. That is a problem. So what we were going through was this what's on chain explorer, and we went through the block headers. What you need to understand is the hash, as I pointed out. This is the Merkle tree I was telling you about, the binary tree, and the block headers are connected with the chain of hashes. The block header is created by having the previous block hash, the current Merkle root, the timestamp, and the nonce joining to create the block hash, which is representing the blockchain. The difficulty is the number of zeros. Let's just go quickly so that we are not repeating at the same time. You're getting the context since we missed the slides. I'm very sorry about that. And you have the same thing repeating to create new blocks. right? The previous hash, the Merkle root, the timestamp, and the nonce. The timestamp is not mentioned here. The simplified payment verification makes sure that you have a scalable wallet system that's implemented in the current Bitcoin Satoshi Vision ecosystem. Transactions have inputs and outputs, and each output is called a UTXO, which is the unspent transaction output. All UTXOs are what are maintained by your wallet and by the miners. Essentially, the list of outputs that are having all the transactions. And this diagram here, which you weren't able to see, which is the most important part, if you are able to see this, you essentially understand the entire blockchain, how it works, how wallets work, and what wallets essentially do fundamentally, right? This is the chain of blocks on the top. There is the transactions that make up the leaf here. The leaf nodes are the transactions. There is the Merkle path of a transaction. The transaction itself, inside the transaction, there are inputs and outputs. So when you receive a coin, you are receiving an output that only you can unlock, because only you have the keys to give the correct input to it to spend it in a transaction in the future. So when you go to make a transaction in the future, your wallet is holding all the outputs you're having, which are the notes and coins of cash. All the outputs, you choose one of the outputs or a few outputs to sum up to the number you want to make the payment of as inputs. You unlock them with your signature or whatever is the unlocking script required to unlock it. If it is a smart contract based locking script, you unlock it and spend it as outputs. Now, there are standard payments, which is the pay to public key hash, pay to key, public key. There is multi-sig payments, multi-signature, and there is custom transactions that you can do with custom locking scripts written, where you can write the locking script you yourself create, paying somebody else any output, and you can write it as, let's say, give me the square root of 2 up till 5 decimal places or anything like that, whatever you want. That's what a smart contract is. So there is a Turing complete language called a script that exists, just like you have JavaScript, just like you have Java, you have Golang, you have many different languages, but they are not assembly languages. They all compile. Java compiles to Java bytecode, and there is a Java virtual machine that runs in any system you install the Java software to, where you need to run Java. That's how you have different languages you can compile. So script is a language based out of TypeScript. It's TypeScript itself, with which there is a compiler written called script that compiles and gives you the Bitcoin virtual machine assembly code to create transactions. So we'll be going in the third session, we will be covering the creation of the custom smart contracts. We will probably take up that example of square root of 2 itself for you to understand. But it's a Turing complete language based out of TypeScript. And with that, you can create any custom smart contract. That's what makes it a general purpose public ledger system and protocol. So that basically brings us to the end of this session. A custom script is the most important you need to understand, and this diagram is also very important to understand. If you have understood this and the importance of how the proof of work algorithm works, you would have understood the core of blockchain, how it prevents spam, and how the blockchain converges to a single longest chain by having the difficulty. We will have future discussion sessions when we will be under projects of comparing it with different other blockchains, how the incentive system actually get changed quite a lot, and there is a lot of misconceptions in the ecosystem with regard to what the blockchain is supposed to do. And that's why there is so many different misunderstandings of that Bitcoin cannot scale, or blockchains do not scale, or Bitcoin can't do smart contracts, or Bitcoin can't do Turing complete smart contracts, or there is not able to be blockchain solutions which require energy efficiency, which are highly energy efficient. So proof of work happens to be the most energy efficient consensus algorithm. But there is again a misconception that because of the restricted system of BTC, there was a huge number of transaction fees and also huge energy cost to create very low output of low transactions. So the transaction cost or the energy cost per transaction was also very high. So it creates a system in which proof of work looks like it's very energy inefficient, when it's actually the Merkle tree technique and all of this creates the most scalable, efficient blockchain system created by Satoshi, designed by Satoshi. So that's how it is. And in the next session, we'll have the hands-on SDK session in which there will be a gist given to you, and you will have to upload the code in a GitHub of your own as well. Uh, After writing the and deploying your custom transaction, in which you have to mention the transaction ID or the chain or the link of the what's on chain transaction at the end of it, and that will qualify you that you have completed that session. Today marks the end of the theory session, and if you have any session, any questions, you can ask it, right? Aditi, what you can do is you can go back through the video. It will be there on YouTube. You'll be able to go back and watch the video, even though it was stuck on the What's on Chain screen for like 15 minutes. I'm very sorry about that. You will be able to see the screens, the next screens, and still be able to listen to the audio of that. And we'll try to even edit it and make sure you have a complete uh, audio along with it. So that's all. And tomorrow we'll be having the session as I told you about, where we'll be going through the wallet development. So you will have a SDK used to create a wallet of your own, a key pair, and then you will create a transaction successfully. What is the requirement for tomorrow? So before tomorrow, make sure you have JavaScript installed in your system. And JavaScript Node.js is what needs to be installed. Node.js version has to be greater than 16. The schedule will be shared by Rebecca. Please contact on Discord, or I think it will be shared. Attendance for that, you have to mark it on the QR code shared in the middle of the session. If you have missed it, make sure to watch the YouTube recording of this, and you'll be able to get the QR code of the session to mark your attendance. Is the knowledge of Bitcoin assembly language required to create smart contracts of a script, or it will be sufficient? It will be sufficient, but the UTXO model of inputs and outputs, what I shared with you, is very important to understand. And it's always better to understand how the assembly language is just functioning, or just the stack machine is functioning. That's why we have made sure you complete your script, Bitcoin script course. So that's the certification requirement for you to qualify as a rookie developer. So if you complete the course of Bitcoin script, which is a requirement also given to you from the BSV Academy, you will learn everything about the Bitcoin script. This does not have that course does not have the theory of what I told you about today, of basics of blockchain and how the blocks are working and the entire thing. You have only Bitcoin script getting taught there. And Bitcoin script is not necessary for tomorrow's session. For next session, next weekend, it will be important. So next weekend, when we have the session of the script compilation and we do the smart contracts, that time before that you have to complete the Bitcoin script. And next weekend itself, we have the rookie phase ending. So make sure you have complete the Bitcoin script, understand the Bitcoin script completely, understand this session, rewatch the videos also to understand this session. Make sure to attend tomorrow's session also. And timestamp will not be shared for the QR code, because the idea is you need to watch the entire video, you need to learn, and that's how you mark the attendance. I know there are many hacks around it, but it's as close as we can get to make sure you watch the video entirely. So that's where we are at. Make sure you attend the sessions. You are seeing the sessions, how they're going to happen. Today, you learned the entire blockchain theory very well. Tomorrow, you're going to make a transaction on the blockchain with code. Make sure you have TypeScript, Node.js, greater than 16 version installed. We'll be sharing the installation instruction with you. Rebecca will be sharing on Discord as well. You'll get an email also for it immediately, and have that ready before the session tomorrow. And you will be able to at least create keys and deploy transactions, create transactions on the blockchain. So that's all, and see you tomorrow then, guys. Thank you. Tomorrow in the afternoon at 3 p.m. You will be getting an invite just like you got for the event notification today on your calendar. But it will be in the afternoon, it will not be in the evening. The course link is shared on Discord as well as on email. We'll be sending it over again. It's at the BSV Academy, and there you can search for the Bitcoin script course, and that's going to give you a mini certificate also, and that's a requirement for completing the rookie phase. This session, you just have to mark your attendance and make sure you watch the video completely. Cheers. Thank you so much. Tomorrow there is a session at 3 p.m. Aditi. Make sure you have Node.js installed before that. And that's all. Thank you.